Okay, so this video is going to discuss how we determine the number of protons, neutrons, and electrons in an element. So referring back to our notes from week 4, the general formula that we're typically given for an element on the periodic table is usually represented by an X with an A at the top corner and a Z in the bottom. And for us, now again, this is just a general representation of an element, but on a test, obviously, you would be given another element, an actual element like calcium or potassium or magnesium as just an example. Now, so for us in our books, the A for us represents the atomic number. And with the atomic number tells us two things when we're determining protons, neutrons, and electrons. The atomic number itself automatically tells us the number of protons we have, and it tells us the number of electrons we have. The second number we see here is the Z, and the Z represents to us the atomic mass. Now, some of you have asked me a really excellent question, which is that in some other examples, whether it's on the internet or in different books, the A and the Z are flipped, or they represent the A doesn't represent the atomic number, but it represents the atomic mass. And either way, both are accurate. And the reason why both are accurate is because every periodic table can be arranged slightly differently. And this is why we have a legend with our periodic table. So the Z in our situation here represents the atomic mass. And the atomic mass will help us determine the number of neutrons we have, because we will actually take the atomic mass itself and subtract the number of protons that we were able to determine from the atomic number to determine the number of neutrons. So when we're dealing with our atomic mass, I'm just going to erase this a little bit so I have some room here. The atomic mass does tell us the neutrons we have. So neutrons equals the atomic mass minus your atomic number. So let's now work on an example with this, like our generic formula here for us. So I'm just going to pick a element at random here. So because I've already mentioned calcium, let's do calcium. So calcium is, if I'm just going to write our element down below, okay, calcium's atomic number is 20. And its mass is 40.078 units, or grams per mole. However, we're just going to use the 40 as the whole number because while we're trying to figure out protons and electrons and neutrons, there's never a decimal of a neutron or proton or electron. So with all other calculations that we would do with like molar mass is equal to grams per mole, we would use all of those decimal places. However, for this purpose, this is why we're not doing that. So the first thing that we're going to figure out is our protons and neutrons, because it is the simplest thing to find. So with our protons and electrons that are automatically equal to our atomic number is 20. So calcium has 20 protons. It also has 20 electrons. Okay? Now, with our number of neutrons, okay, above I said that we take our atomic mass and we subtract it from the atomic number. So we take our mass, which is 40, and we subtract it from our atomic number, which is 20, so we end up having 20 neutrons. I hope this video has helped. Please let me know if you would like to see others relating to determining protons, neutrons, and electrons for our elements on the periodic table.